In March 2003, federal agents arrested a man named Andrew Carlson for what looked like the most successful case of insider trading in history. He had allegedly turned an $800 investment into $350 million in just 2 weeks. When questioned, Carlson claimed he wasn't a genius, but a time traveler from the year 2256 who already knew how the market would perform. The story eventually unraveled as a total fabrication. It originated in the Weekly World News, a satirical tabloid, yet it was picked up by major news outlets and presented as fact. We are drawn to these hoaxes because they align with a cinematic version of time travel that doesn't actually exist. A real time traveler looks more like Russian astronaut Gennady Padalka. By spending over 800 days orbiting Earth at 28,000 kilometers per hour, his internal clock fell out of sync with ours. When he finally returned to the surface, he had technically moved 0.02 seconds into the future. This demonstrates the strict physical law governing our universe. Moving through time does not require a magical machine, but it is bound by a singular direction. The arrow of time only points forward. Physics allows us to accelerate our journey into the future if we can overcome the technological hurdles of speed and gravity. However, those same laws create a logical wall that forbids us from ever returning to the past. For centuries, Isaac Newton's view of the universe dominated. Time was constant, ticking at the same rate for everyone, everywhere. Albert Einstein proved him wrong. He realized that time is flexible, flowing at different speeds depending on the forces acting upon it. The first way to manipulate this flow is through speed. The faster an object moves through space, the slower it moves through time relative to an observer who is standing still. This is known as kinematic time dilation. We confirmed this in 1971 by flying highly precise atomic clocks around the world on commercial airliners. When compared to clocks that stayed on the ground, the traveling clocks were lagging behind by several nanoseconds. The experiment proved that moving fast literally slows your experience of time. This effect is a constant factor in modern technology. GPS satellites move so quickly that their onboard clocks would drift from Earth time if scientists didn't use Einstein's equations to mathematically correct them. Forward time travel doesn't involve a sudden jump. It is a slow, physical process where your biological clock remains steady while the rest of the universe ages rapidly around you. Speed is only one way to alter the clock. Mass and gravity can achieve the same result. Einstein suggested we visualize space and time as a single woven fabric. When a massive object, like a planet or a star, is placed on this fabric, it warps the mesh, pulling it downward into a deep curve. The stronger the gravitational pull, the more time slows down. A person sitting at the bottom of a deep gravitational curve would experience time moving much slower than someone floating in the flat, empty space far above them. We see this at its extreme with supermassive black holes. Their gravity is so intense that they act as natural time-slowing engines. If you survived near the edge of a black hole like M87, you would experience a single hour, while 7 years pass for everyone else. Between high-velocity travel and extreme gravitational wells, the physical universe provides multiple pathways for traveling into the future. While the math of general relativity suggests by a spinning black hole or a wormhole might theoretically bend spacetime back into a loop, the universe appears to have a built-in defense against traveling to the past. Stephen Hawking illustrated this with a party he hosted at Cambridge in 2009. He put up balloons and served champagne, but he didn't send the invitations until after the party was over. He waited for guests to arrive from the future, but no one ever walked through the door. The empty party highlights the grandfather paradox. If a traveler goes back and prevents their own birth, they create a logical impossibility. They never existed to make the trip, so the trip never happened, which means they were born after all. There is also the predestination paradox, where your attempt to change history becomes the very trigger that causes the event to happen. You become trapped in a closed loop of cause and effect that cannot be broken. Stable wormholes would require massive amounts of negative energy we cannot yet produce, but the ultimate hurdle is logic. The universe prevents any action that would break the essential link between cause and effect. We have to accept that space-time is a one-way street. Our only way to interact with the past is passively. Because light takes years to travel across space, Telescopes like the James Webb allow us to capture ancient light, giving us a window into history as it looked millions of years ago. Looking forward, we have theoretical options. NASA has explored the concept of stasis chambers for long-distance spaceflight, where mild hypothermia could slow down a human's metabolic rate, essentially pausing the biological clock for weeks at a time. To reach the future, we don't need to rewrite the laws of physics. We need to solve the massive engineering challenge of generating enough energy to push our technology toward the speed of light. We are all currently time travelers moving at 1 second per second. Our ability to fast forward is no longer a question of theoretical physics, but a question of whether we can eventually engineer the immense energy required to chase the speed of light.